Hi, this is Dr. Xu, teaching design of experiment for engineering research. In the compare of two means experimental example, for each material we have repeated the test for 10 times. So 10 tests for the original material and 10 tests for the treated material. But can we do only 5? Or do we need to choose an even larger sample size? Selection of an appropriate sample size is one of the most important parts of any experimental design problem. We will look into this question by using the confidence interval. We look at the confidence interval of the estimated difference between the two means. This is the equation to calculate the 1 minus alpha confidence interval. It is a measure of the precision of estimation of the difference in the two means. In this equation, this term doesn't involve sample size, and it is a fixed value after we have done the experiment. Thus, the length of the confidence interval is determined by this term only. If we consider n1 equals to n2 equals to n, this becomes 2 divided by n. SP is the pooled estimate of the sample deviation. It is a value relatively constant and we have no control. Thus, the confidence interval is closely related to the value of t by square root of 2 divided by n. Apparently, as sample size changes, the t value will change. Also, this term will change. Let's look at how this value changes with the change of sample size. When alpha is 0.05, so alpha equals to 0.05, that is, if we use a confidence interval of 95%, we can plot this value versus the sample size here. We can see that the curve descends rapidly as n increases up to about 10, and less rapidly beyond that. We can conclude that choosing a sample size of n equals to 10 from each population in a two-sample 95% confidence interval will result in a confidence interval that results in about the best precision of estimation for the difference in the two means. Therefore, for a simple comparative experiment, we normally choose a sample size large or equal to 10 for each population. Before we finish this topic, I would like to show you how I make this curve by using an Excel spreadsheet. In Excel, we know alpha equals to 0.05, and sample size we start from 2. Because choosing a sample size of 1 does not help in statistical analysis. Sample size 3 and 4, and I select this, drag it down to 60. So a sample size of 2 means n1 equals to n2 equals to 2. The degree of freedom equals to 2 times of the sample size minus 2. Enter. Drag it all the way to sample size of 60. The two-tailed t-value can be calculated using this function equals to t dot inv dot 2t. So this 2t means two-tailed. The first parameter is the probability, which is alpha. Select here, comma. And the second parameter is the degree of freedom. Select this, enter. Before I drag it down, so the t-values are calculated for each sample size, I will need to lock this cell, A2, because when I drag this down, I only want this parameter change, but not this parameter. So I'll put a dollar sign in front of A, a dollar sign in front of 2. And then when I drag it down, the first parameter will always be using the cell A2. But the second parameter will use the parameter in front of that cell. Okay, drag all the way down to sample size of 60. Now calculate this value. So equals to t by square root of 2 divided by sample size. Enter. Drag it down all the way to sample size of 60. Lastly, make a graph using the sample size as the horizontal axis and this value as the vertical axis. Firstly, we insert, select here, I'll choose this type of graph. Right click, select data, add. Series name, I will leave it blank. X values, select the sample sizes. Done. Y values, select this column. Enter. OK. OK. Now go back to the chart. We can see the plot. We can do some adjustment to the appearance. Double click here. The major unit for the x-axis, I'll set it 2, and the minor is 1. Axis title, horizontal is sample size, and vertical is that value s by square root of 2 divided by n. Grid line will add primary minor vertical lines. So that's the lines here. Okay, that is how I have made this chart. Thank you very much for watching. This is Dr. Xu. I will see you in the next video.